Hey, Jared. Hey, everybody.
Hey,
Thanks for hopping on. No trade today, so just be Jared and myself. So I figured might as well just go ahead and jump right in. Today we're going to be talking about exfiltration and specifically using Lambda and Lambda functions inside of AWS to perform that exfiltration. So without too much ado, Jared, over to you.
hey everyone, thanks for joining. If you guys have not seen me in the past few TT Lives, I'm the newest adversarial engineer here at SCYTHE, and we're going to be talking about a capability that we have noticed a little bit in the wild, which is using AWS Lambda functions for exfiltration of credentials or of files themselves. For those of you who are not familiar with Lambda, what it is it is basically a serverless function that can be hosted in AWS. It is given an address that you can send data to, and if it's the data that can be parsed by that function, it can basically be sent to anywhere within AWS. For example, you can use it for these purposes. So what we do with this Lambda is two things. We will post base64 encoded data to it, and if it detects that there's possibly credentials in the data based off of keywords and delimiters like commas, hyphens, etc., it will parse those and put that into our AWS Secrets Manager. On the other hand, if you post a base64 encoded file to it, it will send it to S3. And that's done by converting it to base64, and it will arrive as a bin file. Yes, Stacy, it does use post commands, basically. The one that we do when I walk through it, it's specifically using PowerShell invoke web request, which aliases curl, and then will allow you to set those methods like get and post, etc. So without further ado, I will show my screen and we'll walk through this threat here. So first, you guys are going to notice that we have some UI changes in SCYTHE. This is coming soon for any of our SCYTHE users out there. And those of you that do our workshops, you might see that soon too. This is a pretty short threat, and we're going to kind of go over a little bit of this and then kind of show you what it ends up doing on the back end. So what we do here is we create two files that are going to go to the desktop. One is a credential file with creds.txt, and I'll show you how that's parsed once we get into Secrets Manager. And then we also go ahead and set down a zip file. And this zip file, since it won't be able to detect creds in it, it will assume that this is a binary file and will send it to S3 instead. And these requests are done through specifically crafted commands. So we use a PowerShell environment variable to basically convert that file to base64. It's kind of weird looking here, but basically what this string here does is it iterates through the file, reads the file bytes, and converts it into base64. And we're saving it here in this environment variable. And then basically there's going to be this response, which will invoke web request. And again, that alias is out to curl.exe, to the Lambda URL with the post method. And then you have to provide a body. So you would say what type it is for this. We'll say it's text. The data sent across is the base64 environment variable and the file name. And then what it does with this last pipe is it converts it to JSON, and then it is sent off. And when it hits the Lambda, what it will do is it will read that base64, it will reconvert it back to the original file, crawl through that and extract credentials, and then send them directly into Secrets Manager. And what you can do with this, for example, if you were able to exfiltrate credentials from someone's endpoint and put them in your Secrets Manager, you basically have given yourself an easy reference to go back in and utilize those credentials basically straight from Amazon if you want, if they have, if you've, for example, have gotten AWS credentials, or you can just use it as a key store for yourself. The next one.
Jared, too, one piece that I
Yeah.
really like about that. Kind of different than how we do some exfiltration things now when we do probe team engagements and things like that. Is the auto parsing of the file itself to then pull out the credentials and pieces like that. So instead of just uploading a file that you're then going to have to carve through later, this kind of automatically will parse through that, pull out the creds for you, and then push it over to the secrets vault, like you're saying. So it does a little bit of automation in there to save you a little bit of time and just kind of give you the loot all in one spot.
Yep. Yeah, and I'll show that in just a minute here because it is really interesting to see. And then the second one, it's formed basically in the exact same way. But what you will see, the key differences are, other than the file name, is that in the body, type is binary. And this is important. This is letting the Lambda function know that you are not sending it a credential file. Instead, you are sending it just an encoded file. And this is useful, but it does also provide some interesting challenges. Because of the way it's handled, if you're doing a larger file off of base 64, you would most likely have to chunk it and reconstruct it later. But that is a way to exfiltrate files without, for example, sending a massive amount of data at once. If you take your time between requests, you can kind of chunk it over time and exfiltrate something larger with a less chance of being detected. And that's kind of the theory behind doing this Lambda exfil. And finally, after that, it just deleted the files on disk for some cleanup. So I am going to go ahead and show you what that looks like on the AWS side now as well. So in Secrets Manager, what you see is a bunch of these credential pairs. And basically when the Lambda takes in what you mark as credentials, if it finds those delimiters and everything, it will try to classify it if possible. Otherwise, it will just give it an ID and say, if it's 0, 1, 2, whichever location it was, like on the list of creds in that file, and you can open it. And if you retrieve the secret value, you see that it gives you the key. So this is the DB password, purple unicorn, and it gives you the delimiter that it found. We can go to here, retrieve this one. This one's a DB user account. So this is kind of a way that through this function, an attacker could basically give themselves like a lot of extra time and save themselves some time and do it a little more covertly, especially since a lot of organizations are using Lambda in their day-to-day. But we'll get to that in a moment when we hand it over to Tyler. On the other end, in this S3 bucket here, what happens if you put in the body of that request that it is a binary, it will send it to a date stamped backup. And you see this DAT file here, and that just has to be uploaded as a DAT file because it's base 64 encoded. What you can do, you can pull this down, and I think I'll have to switch my my share here, but I will show you in just a second. All right. So ideally, what you will do is reconstruct it on your own endpoint. So,
Jared, it's not up there yet if you're trying to show something.
Oh, thank you. Let me fix that real fast. My apologies. Sorry about that, everybody. There's always got to be one technical difficulty, right?
At least my internet is working today.
Yeah. All right. So you see if you, oh, well, I guess it didn't find it. Okay. Where did you go? You are in my downloads. Okay, another technical difficulty. Anyway, don't want to have to spend too much time on that, but basically what you will do is you would just do the file command, and if it shows that it's the zip file type like you expected, all you would have to do is rename it to exfildata.zip, for example. So let me at least see if it'll let me do that for you. And I'll unzip it and
So you're not sharing anything if you're
yeah, sorry, it's
showing
taking a
us something.
second.
Oh, you're good.
And you will see right at the top here, if you open this exfil.data.zip, there's a creds file. Sorry about the technical difficulties there, everybody. But that's kind of conceivably what you would do. And then if you had multiple chunks, you would just have to build those back together on your own device.
Would you just cat all those files together then, and then just show them all that way? You
Yeah.
just
So yeah.
concatenate
So
all of
what
them?
so you could cat them all out, and then you could combine that base 64 and do that.
Awesome.
Pretty easy to reconstruct.
Yeah, right before we switch over to the detection piece, do you have the Lambda function up to just kind of show what
Yeah.
that look? You don't have to go, obviously
Mhm.
through the whole script, but just kind of walk through how
Mhm.
how that works.
Yeah, so this is kind of the Lambda interface, and what it basically is a little cloud IDE right here. I use Python for it, and you can put your function in here, develop it in the IDE, and you can provide it, for example, test cases to make sure it's processing the data correctly. The thing about Lambda as well is that they are usually accessible, something that you can post to. So if you're using Lambda for certain reasons, you might also, for example, want to require a specific header to be sent across. So if that header is missing, it will just drop it and not process it, so people can't just send things to your Lambda. But this is kind of what it looks like on the code side. You have your bucket set up, and then this is where it parses data. It grabs the JSON, decodes base 64, generates the IDs, and then this is the routing logic. So you can see it tries to find env, JSON, CSV, XML, things that can have credentials or other nice loot to be exfiltrated. And then it will log it to CloudWatch for you. So if you're doing this unattended, for example, like the adversary is doing this unattended, they'll have it logged for themselves. And just to fool the blue team, the returned response on this says that it's coming from this random CDN with, a bunch of junk data. But that's just about everything. The rest is just a little more logic on how it extracts everything out.
Yeah, awesome. Yeah, I was just curious what it looked like, if if someone was going to make it,
Yeah.
kind of where they would go and just kind of how it looks. Yeah,
Mhm.
that's awesome. And yeah, kind of the point you had hit on too, kind of said a few times is we like to use AWS or M365, Azure, GCP, things like that in a lot of these exfiltration attempts because more than likely AWS is open in your environment anyway. Most people have some kind of connection to AWS
Mhm.
in some form or fashion, whether you're hosting something up there or it's just a part of your standard kind of work or S3 bucket or things like that. So utilizing functions like this and utilizing kind of like the native capabilities of
Mhm.
AWS and some of these cloud platforms really does help you blend in, and you can almost assume that it's going to be allowed
Mhm.
through your firewalls and your edge devices and things like that.
Absolutely.
Awesome. Well, I think with
Oh,
that
oh
we
yeah, Stacy. Yeah, so yeah, it is all HTTPS as well.
awesome. Well, with that we can switch over, I think, to
Yeah.
some quick detections for you. Ooh, let me zoom in. It always zooming in to like 175 over here, and it still looks small. Okay, that'll be all right. So not a ton of detections for this because we're not really monitoring any of the AWS. We don't have any like AWS logs in here because this would be hosted on an adversary's infrastructure, right? So you wouldn't be able to see their logs as a defender. So just focusing on the host logs, kind of like we always do. Um, First one up is just looking at some DNS queries to the Lambda function from suspicious processes. So this is pretty akin to what we talk about every Threat Thursday in watch what PowerShell is doing, watch what CMD is doing, and watch what programs outside of system 32 and programs outside of program files and things like that. Watch what they're doing. That's where adversaries like to live, because things are writable. It's living off the land, pieces like that. So here we're specifically looking for PowerShell making a DNS connection out to, basically wildcard Lambda URL wildcard, right? Any Lambda function, or excuse me, any Lambda URL query that's that someone would run. So we see here it's all going to the same one, this dox your Lambda function URL, your Lambda URL will be persistent to each Lambda instance that you make. So even if you do utilize Lambda for whatever reason, and I'm going to try to stop saying Lambda so much, even if you do use that in your environment for whatever reason, legitimate reasons, it should be pretty easy to have a list of, known good or known used. I don't like to use the term known good that much, because you never know when things that are good could be turned bad, but kind of a lower risk kind of threshold of ones you already use, things that are legitimate. You could have that in here, and then just filter those out. So any other kind of URL that someone is trying to reach should rise up to the top, right? And then down to kind of the kill chain. So what this does is that it's tracking it by this process GUID here. So we got that from knowing what the process is that's running, and we're looking at literally just like it's saying here, this exfil chain kind of in order of what's happening, right? So we see an initial connection out to these AWS IP addresses, out to the URL, doing some DNS requests to make sure it can connect to it, and then just some more connections and DNS connections out to this Lambda URL instance. That's another way to view it. You could take some of these process GUIDs and throw them in and see what other, you can see what other URLs they're reaching out to, or what other processes are being created from this process GUID. Just another way to kind of track the process tree of exactly what's happening inside of your environment. This is a good one. It's similar to what we're showing up here on the top of like these DNS requests of PowerShell of reaching out to the query name. Just kind of another way to take a look at it. And then the last one we have is just process creation from process creation when we are running that that command to do the exfiltration, right? So this is looking at process creation of event code 1 in sysmon, or 4688 in your security logs, and it's pulling the command line arguments out and then parsing all of these from those command line arguments. So in the command line arguments, like Jared had shown, it says what the exfil file is. It has a URL in there. It has the method and everything else. We use some regex magic in here to pull those parameters out. And then here it really kind of tells the story of what's happening, right? The admin yesterday, the admin did a post request to this Lambda URL. They sent it this creds.txt file, and it was spawned by PowerShell, right? So really like this last one, it really makes a very clear picture of what's happening, what the adversary did, and what files were exfiltrated, right? So with that, that was pretty much all that we had for this one. Kind of, well, I'd say quick, but we're almost at 20 minutes already. So yeah, Jared, any last words, or any last bit?
No, I think you nailed everything with the detections and kind of how you have to monitor things in kind of the modern environment where this traffic is super common.
Yeah, for sure. But I say it's something we hit on all the time. Every Threat Thursday probably is like, you need to know what is in your environment, what is normal. If you don't know what's normal, you're never going to be able to find the bad guy, right? There's a quote from SANS, the not school, but the educational SANS, where it's like no evil, find bad, but you need to know what's in your environment, or you're going to be looking for a needle in a needle stack, right? You're never going to find it. So with that, I think that is everything. Thanks everyone for hopping on. We will be back in another 2 weeks. Maybe we'll have trade this time. We'll see. Yeah, thanks everybody. Hope to see you again
everyone
next time.